students, good afternoon. Now we have to discuss about the most important topic, that is inert pair effect. Why we have to discuss about this? As I said in previous class, as we are going down, there are two valencies. One is group number and group number minus 2 valencies possible. So as you observe that why group number minus 2 valency or oxidation state is more stable, we have to understand. So reason for that is inert pair effect. What the reason? Why group number minus 2 valency or group number minus 2 oxidation state is more stable as going down, means due to inert pair effect. Okay, so let's see what is the inert pair effect. Inert pair effect means actually what happens as you are going from left to right and as you are going from top to bottom. So the bottom elements will come after D and F block elements. So for the bottom elements in P block, why I am showing here P block, you have that side, right side. So P block, in P block, the bottom elements, here you have a P block, right? P block, right? Here boron family, boron, aluminium, gallium, indium and thallium you have. This is third year. So before this, here, this after maybe here zinc, cadmium and mercury. So this all this is having 3D and this is having 4D and this is having 5D. And here if you see, it's a sixth period. Second, third, fourth, fifth, sixth. In sixth period, there is a 4F series. Correct? So the inner subshells are 4F and 5D. So here you have a T block. So for indium and thallium, before elements are mercury and some F block elements. So the inner subshells for thallium is D and F, which are poorly shielded. Do you know order of shielding? Order of shielding effect is more for S than P, than D, than F, I said. Understanding what I am saying? For P block, bottom elements, okay, for bottom elements, the inner subshells are D and F subshells, which are poorly shielding. Which are what? Poorly shielding. So, what happens? Boron family is third year group. The general electronic configuration is Ns2Np1. If you see boron, 1s2, 2s2, 2p1. So 2s2, 2p1 is the configuration, outer shell. For aluminium, 1s2, 2s2, 2p6, 3s2, 3p1, total 13 atomic number, you can check. It's 5. It's a 13, 5 plus 8. And here 3s2, 3p1, that means here 4s2, 4p1. Here 5s2, 5p1. Here 6s2, 6p1. Why you are giving all these things? So to say mainly two things. For bottom elements, the inner subshells are D and F, because in sixth period, you know that. You know already, few people, not few people, many people know that. In sixth period there is a F series, 4F series, lanthanoids. So for thallium, the inner subshells are 4F and 5D. Here and here somewhere 4D, means pore shielding is there or not? Tell me. So due to pore shielding effect of these 4F or 5D or some other next group, next period means 5F and 6D, due to pore shielding effect of D and F subshells, these outer S electrons will penetrate towards nucleus. If inner subshells are this, here you have 5D, here you have a 4F. These are poorly shielding. Pore shielding. Due to pore shielding, for thallium I am writing. For thallium, the inner subshells are 4F and 5D. So what is the outer subshell for thallium? The 6s2 and 6p1. So if these are poorly shielding, S electron penetrate towards nucleus. So these S electrons. How many electrons? 2 electrons. That's why pair I said. See. So these S electrons, 2 S electrons, okay, pair of S electrons otherwise, what I said? Pair of S electrons will attract towards nucleus, so they won't involve in bonding. They won't involve in bonding. So these S electrons, this pair of S electrons will show some inertness to form a chemical bond. So why they are showing some inertness? Inertness means they are saying, I'm not interested, like that. They're saying, lako lako. Okay, they're saying, oh please, I'm not interested. Why? This pair is attracted towards nucleus. So how many electrons involved in bonding? Just one electron. So the pair of electron is showing some dislike to form a chemical bond. That is called inert pair effect. So inert pair effect means the pair of ns electrons show what's a show inertness to take part in chemical bonding. That is called inert pair effect. In that name only you have inert pair, means pair of electrons showing inertness to take part in bonding. Inertness means dislike. They are not interested to take part in bonding. Why they are not interested to take part in bonding? Because those pair of electrons attracted towards nucleus. Understood clearly? So what is inert pair effect? The outer ns electrons show inertness or dislike to take part in chemical bonding is called inert pair effect. Or the reluctance, we can use another word. Reluctance means dislike, nako, Hindi. Understanding what I am saying? So the reluctance of ns electrons to show what? Chemical bonding nature. Okay, so simple definition I will give right out. The reluctance of ns electrons to take part in chemical bonding is called inert pair effect. Why inert pair effect is happening? Because as going down, the bottom elements have inner subshells as D and F, which are poorly shielding. Due to poor shielding, S subshell is spherical and which is small. So penetration order I was given. Penetration. Order of penetration power. Penetration power is more for S than P, than D, than F. I was given difference between shielding and penetration. Shielding by outermost, penetration by inner subshells. Oh shit. Shielding by inner subshells. Protecting by inner subshells. Penetrated means attracted by outer subshells. Penetration power for outer subshells. Shielding for inner subshells. Sorry. Understood, sir, everyone? So S orbital is more penetrated. Now why not, sir? P is having big size, optimum size, so it won't attract towards nucleus easily. So the 6s electrons are attracting towards nucleus. Certainly 2 electrons are attracting towards nucleus means what you can say for third year. Group number means 3. So group number -2 means 3 minus 2 1. And this group number -2 is more stable, I said. Why it is more stable now? Tell me. Because, okay, understood, sir, everyone? So for third year, group number -2 is why more stable. Why -2 I did? Because 2 electrons attracting towards nucleus. That's why -2. Why group number -2 we taken? Understood? Because -2 why we taken? Because 2 electrons, outer S electrons attracting towards nucleus due to inert pair effect. Got it, sir, everyone? What is inert pair effect? The reluctance okay, reluctance of S electrons What electrons? Outer s electrons. Reluctance of outer s electrons. How many? ns2. Why? Due to poor shielding effect of inner d and f substance. So what I said, understood? So as going down, this you know already, as going down, the bottom elements has group number -2 valency, more stability due to inert pair effect. What is inert pair effect? The reluctance of ns electrons to take part in chemical bonding. Why they are showing this like? Because outer s electrons attracting towards nucleus. Why s electrons only showing reluctance? Because these s electrons are sphericals. So s orbitals are more penetrated towards nucleus. So these are attracting towards nucleus due to poor shielding effect of 4f and 5d. So why? Otherwise you will ask me, no, so why not here in boron there is no penetration? Because in boron, who is the inner subshell? S. S orbital has more shielding, this protecting. So this outer electron is not attracting towards nucleus here. Understanding? In case of boron and aluminium, the inner orbitals are not d. So shielding effect is more here for boron and aluminium. So the inner subshells are pushing the outer electrons. So outer s electrons are not attracting towards nucleus in case of boron, aluminium, even in gallium. Gallium somewhat, but still that effect is more. Its shielding effect is more in boron and aluminium. Certainly these outer s electrons are not attracting towards nucleus. So here group number only more stable, but as going down, group number -2 is more stable. So what is inert pair, understood? So slowly I was given, so please have a screenshot everyone. So for third year, group number is 3 valency, group number -2 means 1 valency, 1 is more stable. Why we taken -2? Why not -3? Why not -4? Why group number -2 only? Because 2 electrons attracting towards nucleus. Which 2 electrons? S electrons. Okay, so please note it down. The inert pair effect definition, write down one more time. The reluctance of ns electrons to take part in chemical bonding. So what is the inert pair effect? You have idea now. Okay, inert pair effect. So due to inert pair effect, as going down, which valence is more stable? Which valence is more stable? Group number -2 valency is more stable. So for third year, boron, aluminium, gallium, indium and thallium, if you see. So actually group number is 3. So as I said, ns2np1 for all, 2s2p1, 3s2p1. So for thallium, if you see, it's a second period, third period, fourth period, fifth period, sixth period. How to write electronic configurations? You must know the group number. This group number will give a number of valence electrons. See, third year, 2 plus 1, 3. P subshell starting, so ns2 np1. P block starting, no, boron family. Correct? So here ns2 np1. So here what is the group? 2. So 2s and 2p orbitals will be here. 3. So here 3s and 3p. What group this is? Third. So 2 and 1. 3 electrons only present now. How to fill 3 electrons? S will have maximum 2 electrons and third electron in P. That's it. So this one is 4s2 4p1 and indium is a 5s2 5p1 and here 6th period 6s2 6p1. No need to write from beginning itself. 6th period last before thallium, here mercury will come because it's 31. Correct? 13 plus 18. 31. 30 is zinc here. So here what will come before this? Zinc and cadmium, Cd. Here what will come? Cadmium and mercury. So here D block elements. So here 5D will fill. Here 5D10. Here 4D10. Here 3D10. Like that. Electronic configuration is very simple. No need to write from beginning itself. 1s2 2 This much means you will get this much of electronic configuration. Simply outermost is enough. So why given again? So in thallium, NR subshells are D and F for F. So in thallium, these 6s electrons will show reluctance. Reluctance means dislike. They are not interested to take part in bonding. So for thallium, there are 3 valencies. Valency 3 possible and valency 1 possible. So 1 is more stable. Why 1 is more stable, understood? Sure. So third boron, aluminium, gallium, andium, thallium. Okay, finally, so thallium 1 is stable, group number -2 because 2 electrons are inert pair effect. These s electrons are attracting towards nucleus. So TlCl3, TlCl, which is more stable means TlCl is more stable. Why? TlCl means here thallium valence is 1 because 1 chlorine. What is valence? I said the combining capacity of atom with number of hydrogens or number of halogens or double the number of oxygen atoms. So here thallium combined with 3. So here valence is 3. Here thallium combined with 1 chlorine. So here thallium valence is 1. So for thallium valence 1 is more stable. Same story for carbon, silicon, germanium, tin, Sn and lead if you see. Bottom elements are not writing, so no need actually. 7th period. So here carbon family is 4th A. So it's a second period, 3rd, 4th, 5th and 6th. 4 electrons means Ns2, Np2. So here it is 2s2 and 2p2, second period. 3rd period, 4th period, 5th period and 6th period means the outer subshell configuration means valence shell configuration I am writing 6s to 6p2. So again for lead there are 2 valencies are possible but s electrons show reluctance because as going down the inner subshells are D and F. So 4 valence is possible, 2 valence is possible but 2 is more stable. So PbCl4 and PbCl2, which is more stable means PbCl2 is more stable. How we are writing 4 and 2? Because 4 valence is possible, 2 valence is possible. With oxygen also, PbO2 and PbO, which is more stable means PbO. Oxygens means double the number we have to consider. I told or not? So 2 oxygens means lead valence is 4, double consider. 1 oxygen means lead valency is 2, double we have to consider. So here 2 valency, here 4 valency. 2 is more stable, PbO is more stable. PbCl2 is more stable. Understood? So this is about the valency. Got it, sir, everyone? So in valency, you have to remember all these things. PbCl4 stable or PbCl2 is more stable like that. So valency understood? So clearly, okay, sorry, you have to write all these things. Please note it down. Okay, why as going down group number -2 valency is more stable. So please have a screenshot and write down. Okay, sir. Next, we have to discuss about oxidation state. Okay, we have to discuss about what's a oxidation state. Same. If you know this valency, oxidation state will be very easy. Oxidation state of atom you will have in combined state only. Okay, so elemental state means how exist in nature. Elemental state means isolated state. So atoms in isolated state there is no oxidation state. Oxidation state will be 0. What is elemental state understood? H2, it's a elemental state. Elemental state means how exist in nature. Hydrogen is diatomic, so H2, H single bond H, night N2, O2. Okay, these all are called elemental state, how they exist in nature. So for elemental state atoms, atoms oxidation state will be 0. Okay, so in previous we discussed about valency. Valency means combining capacity. how many bonds atom forming. But oxidation state is a formal charge on atom which is due to unequal sharing of electrons or else maybe loss of electron or gain of electron. Due to loss of electron, atom gets positive oxidation state. Due to gain of electron, atom gets negative oxidation state. Suppose if you take sodium loses electron, Na plus and 1 electron. So here plus 1 is the oxidation state. Cl will take 1 electron and form Cl minus. Okay. So here oxidation state is minus 1. Oxidation state can be 0, negative, positive, fractional also. Yes, fractional oxidation state also there. One chapter we have, redox reactions. Okay. So there oxidation states we will discuss. So what is the oxidation state therefore? Oxidation state means the formal charge exists on atom due to loss of electron or else gain of electron or else unequal sharing of electron. So as I said, HCl, who is more electronegative? Electronegativity is more than negative oxidation state among the atoms which are in bonding. More electronegative atom, negative charge. Less electronegative atom, positive charge. Understanding? So hydrogen electronegativity value, see electronegative value is how useful, and chlorine 3. So chlorine minus, hydrogen plus. Unequal sharing. How you came to know, sir? Chlorine electronegativity is more 3. So these pair of electrons, one bond means 2 electrons or not. This pair of electrons slightly displaced towards chlorine. Like one chocolate sharing by hydrogen and chlorine, they won't share equally. This take more chocolate, chlorine. Why? Because it is more electronegative, more attracting tendency. Understand? So chlorine gets minus, so minus 1 oxidation state. Here plus 1 oxidation state. Okay, so oxidation state means how we decide. More electronegative atom has negative oxidation state in bonding. Okay, so like H2S or anything else, NH, NF3. Okay, nitrogen positive oxidation state here. Fluorine negative oxidation state here. Because F minus, because fluorine electronegativity is 4, nitrogen is 3. Among N and Cl, chlorine is negative and nitrogen is positive. Even electronegativities are same. I said the bottom elements have negative oxidation states like that. Do you remember? So that is very, very important. Please remember and have a screenshot. And here also I will give oxidation states for each and every group in general. What is the general oxidation state of 1A group elements and 2A group elements, like that I will give you. Same story up to 4A group elements. So what I will give now? General oxidation states of S and P block elements. Why not D block? D block elements and F block elements, they are called some transition elements. I told you, they exhibit variable oxidation states, means they exhibit many oxidation states. But S and P block elements have some certain oxidation states, some fixed oxidation states. Okay, so we will discuss oxidation states of S and P block elements right now. Okay, so again same story, 1A and 2A, 3A and 4A, 5A, 6A and 7th and 8th. So here also I will give one same thing. up to 4A group, up to what's a 4A group, oxidation state is equals to group number. Up to 4A group, oxidation state is equals to group number, but group number plus oxidation state means we have to mention whether it is plus or minus. Okay, but valency no need. Plus valency, sir, minus valency. Valency is a capacity, but it's a charge. So we have to mention that is a positive charge or negative charge. Okay, so very important. So up to 4A group means up to carbon family. 4A group means what family? 4A group is called carbon family. Okay, up to 4A group, oxidation state is equals to plus group number, and from 50A to 8A, 50A to 8A, oxidation state is equals to group number minus 8. Group number minus 8. What is that understood? Are you thinking I written wrong? Valency means 8 minus group number, but oxidation state group number minus 8. Valency means what I said? Valency means 8 minus group number, because valency never be negative. Valency is a capacity, but oxidation state can be a negative also. So from 50A to 8A, oxidation state is group number minus 8. Got it, sir, everyone? So please remember, up to 50A, oxidation state is plus group number, and from 50A to 8A, oxidation state is equal to group number minus 8. Okay, and two more. As just in valency, what we discussed, same manner. As going down in P block, not in S block. In S block, always only one oxidation state. 1A group number plus 1, 2A group plus 2, group number only. But as going down in P block, there are two more oxidation states, two more but positive oxidation states. Two more positive oxidation states. They are, one is plus group number and second one is plus group number minus 2. Positive only will come. And same story as I said, which one is more stable as going down? Group number minus 2 oxidation state is more stable as going down. So very simple, now write down general oxidation state. General oxidation state means these two. These two are general oxidation states, and this one is as going down in P block it happens. So as going down in P block, the bottom elements exhibit two oxidation states. One is positive group number and one is positive group number minus 2. And as going down for bottom elements in P block, group number minus 2 oxidation state is more stable due to inert pair effect, what we discussed. Got it, sir? So let's see what is the general oxidation state of 1A, always plus 1, for 1A plus 1, for 2A plus 2, for 3A plus 3, for 4A plus 4. What is the general oxidation state from 50A to 8A? 50A to 8A. Group number minus 8 means 5 minus 8 minus 3, 6 minus 8, 6 here, 6 minus 8 minus 2, and how to write 5 minus 8 like that. Okay, if you want I'll write 5 minus 8. This one 6th group now. So 6 minus 8 minus 2 oxidation state, please round up, otherwise you will confuse. It's minus 1 and 0 because 8 minus 8. And as going down, two more oxidation states, group number oxidation state, group number oxidation state, that is for these nothing. Group number means already I written plus 3 and plus 4 only group number oxidation state. If you want again you can write plus 4 plus 3. But for 1A always plus 1. Alkali metals oxidation state always plus 1. Alkaline earth metals oxidation state always plus 2. Pakka. Okay, so this one group number minus 2 oxidation state. Here plus 3, plus 4 and plus 5 is plus 6, plus 7 and plus 8 are possible. But these are possible as going down. Understanding? So in these group 58 plus 5 possible, plus 6 possible, plus 7 possible, plus 8 possible. Okay? For nitrogen, no, plus 5 like that. Okay, different oxidation states, exceptions are there due to electronegativity values, but in general I am saying all these things. Okay, don't fix for this. You said no sir, minus 3 only for nine. Some other also possible, but nitrogen with fluorine is more electronegative. So nitrogen certainly has positive oxidation state, but these are in general I am giving. Understood? So group number minus 2 means 1 plus 1 plus 2. I was given in previous also. 1, 2 plus 3 and plus 4 and plus 5 and plus 6. But as going down, which one is more stable? For third year, plus 3 stable or plus 1 stable as going down? For thallium, sir. Thallium is the third year group element or not? Bottom element. So plus 3 possible, plus 1 is possible. So plus 1 is more stable. Reason understood everyone? Inert pair effect. Same story. That's why inert pair effect is very important. So for 1A and 2A, only one oxidation state. For 1A, always plus 1. For 2A, always plus 2. But for 3rd A and 4th A, 2 oxidation states. And for 5th A, 6th A, 7th A and 8th A, there are 3 types of oxidation states. Because here group number minus 8 is there. And group number minus 2. What is the group number oxidation state of 5th A? It's very simple, no? Plus 5. As going down, which oxidation state is more stable for 6th A? As going down. Okay. 6 minus 4. Sorry, 6 minus 2. Shit. 6 minus 2 plus 4 is more stable as going down. Understood? Some different oxidation states, some fractional oxidation states also possible. Remember, oxidation states, not only these, few more are there, because oxidation states depends on combination of atoms in chemical bonding and electronegativity values. So we will discuss everything in redox reactions later on, but in general we have to learn these oxidation states. So please have a screenshot along with me. No, not me. So please write down. Thank you. Okay. So please practice, almost completed, and acidic character and basic character remains, and those also we will discuss in next class, and we will enter into chemical bonding chapter.